Alright, so this is the exam for review part 3. This thing is getting really long. Let's go ahead and get started. So it says write each expression as a single log. So basically this is the kind where we condense. We take 2 or 3 logs and condense them into one. So let's go ahead and look at letter A there. So I could distribute the 1/2, but if you look inside the parentheses, you can use the product rule and combine that into the log of xy. So let's do that first. So we're using rule or property 1. So this is 1/2 the log of xy. And so now we can move that to be an exponent using the power rule. And remember, anything to the 1/2 is a square root. And everything inside the parentheses goes under the radical. So that's it for A. Let's look at B. So can't use the product rule or the quotient rule because of the numbers out in front of the logs here. So the first thing we need to do is move those to become exponents. So basically I'm going to move the 2 as an exponent there and the 1/3 as an exponent on the y there. So let's do that. And we can rewrite x to the negative 2 power. In fact, we know negative exponents lead to reciprocals. This is 1 over x to the positive 2 power. And the cube root of y, or anything, y to the 1/3 means cube root of y. So let's go ahead and rewrite that. And so now notice I can use the product rule, so rule 1. And so yeah, when we multiply those, we're going to get y, the cube root of y in the numerator, and x squared in the denominator. Alright, let's move on to C. So again, just like the last problem, for the first 2 expressions there, we're going to need to use a property 3 to move those to become exponents. So it's log base a of 81 to the 1/4 power minus the log base a of 4 squared plus the log base a of 7. Now 81 to the 1/4 power can be written as the 4th root of 81. And this actually can be simplified because if you look at, we're basically looking for something that you take to the 4th power that gives you 81. Whoops, I messed that up. Let me see if I can fix that real quick. So we're looking for something to the 4th power that gives us 81, and that would be 3. And so the 4th root of 81 is 3. And so let's go ahead and fix that first logarithm. It'll be log base a of 3. And then on the second one, 4 squared, of course, is 16. So we'll get minus log base a of 16. And then plus log base a of 7. So now if you look at the first 2 logs there, we can use the quotient rule. So let's go ahead and do that. We can write it as 3/16, the log of base a of 3/16. And then plus log base a of 7. And now finally we can use the product rule. Notice that 3/16 times 7 is actually 21/16. So this final answer is a log base a of 21/16. Let's look at letter D now. Now I think I told you didn't have to worry about this one. This is one that is there's just really one thing that makes it a little more complicated, but it does definitely add to the problem some challenges. But it's not real typical of what you're actually going to need in the future. So anyway, if you're interested, you can see how I did it here. So first of all, I want to use the power rule to get rid of those numbers out front. So that's what I did first. And of course, x to the 1/2 power, we can write that as the square root of x. Let's go ahead and use the product rule next. So it'll be log base b of x to the 1/2 power times y to the 7th minus the log of x cubed. Oops, I should have a base b in there. So now we can use the quotient rule here to combine these two logs. And the thing is, look at the x's there. We've got an x in the numerator and denominator. We actually need to use the quotient rule for exponents. So I'm going to do that off to the right side here. If you have x to the 1/2 over 3, the quotient rule says we need to subtract these exponents. So it'd be x to the 1/2 power minus 3. Since I need a common denominator when I subtract fractions, I'm going to write 3 as 6/2. And so 6/2 is 3, but now I have a common denominator. 1/2 minus 6/2 is -5/2. And then finally I need to write that as 1 over x to the 5/2. And so what we end up with is the log base b of y to the 7th over x to the 5/2. And believe it or not, I could actually redo or simplify this more if I changed it to radical form, but we're just going to leave it alone like that. Alright, let's move on to the next problem. It says use the change of base formula in a calculator to evaluate to 4 decimal places. Now first of all, if you have a TI-84, you don't need to worry about this unless you have one of the first ones that was made. You can look under the math menu, of the first column, and look for log base, and you can use that to evaluate these if you have that feature. Otherwise, you have to use the change of base formula. Certainly on the TI-83 you'll need to do that. And so all we do here is we write this as the log of 4,000 over the log of 12. I just think of it as the log of the higher number over the log of the lower number. That's all the change of base formula does, is we just change the base to a base that we can put into our calculator. Notice these are base 10 logs, and we can use that LOG button on our calculator now. It's important to put that parentheses around the 4,000 in particular, and if you do put it in like that, you should get 3.3378. Now notice you can check these answers. Remember, a logarithm here, the logarithm base 12 of 4,000, the log is an exponent. It's the exponent you put on a base of 12 to get 4,000. So it should be true that 12 to the 3.3378 power is 4,000. And if you check that, you can verify that that's true. So on the next one there, this will be the log of 7 over the log of 0.5. And you should get negative 2.8074. And again, if you took 0.5 to that power, you should get 7. Let's go ahead and move down to the bottom there. Let's see. Solve the following equations, find the exact answer, and if necessary, use your calculator to give a decimal approximation to 3 decimal places. Alright, so we'll get into how the different varieties of logarithmic equations and basically our strategy, but whether we're solving logarithmic equations or exponential equations, probably one of our key strategies, one of 2 key strategies, is to change forms. So here, notice 5 to the x power should equal 1/25 if we change this to exponential form. So we have 5 to the x power equals 1 over 125. And we know 5 cubed is 125. So x would have to be negative 3 here. Alright. Now on the next one there, we're looking at an exponential function. I'm going to go ahead and give you the 2 methods that we're going to use to solve these, the ones that we talked about in class. So for exponential equations, First of all, if we can get our bases equal, we're going to do that. We learned that if our bases are equal, that our exponents are going to have to be equal in order for the two expressions to be equal. So I call that equal bases. And then the other one is we have to switch forms, which we talked about. So those are our two strategies when we solve exponential equations. So in this problem, notice we've got a base of 4 on the left and a base of 16 on the right. We can certainly write 16 as 4 to some power, be 4 squared. So let's go ahead and do that. And so here's a case where we have an exponential expression equal to another. They both have the same base. So the only way these could be equal is if the exponents were also equal. And so let's set them equal. 3x minus 5 equals 2. We'll add 5 to both sides, divide by 3, and we get 7/3. All right, let's move on. So both of these problems are similar to that one. We're going to have to get our bases, or we're going to be able to get our bases to be the same. Look at letter C here. Unfortunately, if you look at the powers of 9, 9 to the first is 9, and 9 squared is 81. We can't write 27 as 9 to some nice power. So we're going to have to change our base. In fact, we could go small. Well, we need to go smaller, and 3 would be, we could write 9 as 3 squared. And we could also write 27 as, or using a base of 3, 3 cubed. And so this becomes 3 squared to the x plus 2 is equal to 3 cubed to the minus x. So all we've done is replace 9 with 3 squared and 27 with 3 cubed. Now we can rewrite this equation so that we have a base of 3 on both sides. And now the only way this equation could be equal or true is if the exponents are also equal. Actually, I'm going to distribute first there. So basically, our exponents must be equal in order for these two powers of 3 to be equal. And so let's set the exponents equal. And I'll subtract 2x on both sides. And then we'll divide by -5. We're going to get -4/5. Notice D is triple starred. If I gave you something like that on the test, it would be as an extra credit type of problem. But I'll go ahead and do it here. 1/32, well, if you could recall that 2 to the 5th power is 32, that means 2 to the -5 power is 32. So I can write that as 2 to the -5 power to the x power. On the other side, we can write 8 as 2 cubed. And so now we're going to use the product rule, so we'll multiply our exponents, -5 times x. And notice when we multiply 3 times x plus 10, we do have to distribute. We're really doing 3 times x plus 10. And so we get 3x plus 30. So again, we can set our exponents equal, because that's the only way. If you have two powers of 2 that are equal, the exponents must be equal as well. So let's set them equal. And let me subtract 3x on both sides. And we'll divide by -8. And we get -15/4. All right, let's move on. So as you look at E, you can see that we're not going to be able to write 137 as 4 to some power. So equal bases is not going to work. We're not going to be able to get our bases equal like we were doing before. So this is a case where we want to switch forms. And so we have a base 4 here, so it's going to be log. So we're going to switch forms. Log base 4 of, let's see, we put the exponent by itself, and the answer goes right there. And so in this case here, if you have the TI-84, you could put that into your calculator. If you don't have one, then using the TI-83 or a scientific calculator, you're going to have to put it in as the log of 137 over the log of 4. So we're using the change of base rule. And so you get 3.5490 when you do that. And actually, I think it says to approximate to 3 decimal places, so I've gone an extra one. The thing about it is you can check these answers, which is really nice. You can do that with all of these and know that you did your work correctly. Notice as a check, if we take 4 to the 3.5490 power, you do get 137. Now it may not be exact, but that's because we're rounding here. I usually round to 4 decimal places, but here you really only had to give 3. Let's move on. So again, I've rewritten this in logarithmic form because I can't write 210 as a power of 5. And so this is similar to the last one. Let's go ahead and use the change of base formula here. So basically, we have the log of 210 over the log of 5. We're going to have to find that. Notice to get x by itself, we need to subtract 3 on both sides. So basically, once you put that fraction into your calculator, you just need to subtract 3, and you should get this answer that I just gave you here. Again, I'm going an extra decimal place. You could have stopped at 2 there if you actually followed directions. I'm not following the directions here. On letter G, this is going to be a base E log. Let's see, the exponent goes all by itself on the other side. The 4 goes right there. Now I'm going to write this in the natural log form because we don't usually write log base E. That's what natural log means. And so now we just need to divide by negative 0.5. And I'm going to pause this. Alright, so we divide by negative 0.5. And you should get about negative 2.7726. So if you rounded to 3 decimal places, you would have said 773 there. Let's move on to letter H. So again, we can't write 3 using a base of E, so we're going to switch forms. You should get natural log of 3 is equal to 5x plus 4. So first thing I want to do, I'm trying to get x by itself, so I want to get rid of that 4. And so you get natural log of 3 minus 4 equals 5x. Now, it might be tempting to subtract 4 from 3, but when you have natural log of 3, that all goes together, and the 4 is not a logarithmic term. It's just a number. It's totally separate, so we'd want to write it just like I wrote it there. And then now we need to divide both sides by 5. And so you get the natural log of 3 minus 4 all divided by 5. Just be careful when you put this in your calculator. You might want to you need to hit enter after you put the numerator in and then divide by 5, or put the numerator in parentheses. And so you should get negative 0.5803. Now if you look at letter I, you've got an extra number, that 9 there. Notice if you have e to the x power equals 5, you'd be alright. You'd have your 3 parts, base, exponent, answer. So the 9 is an extra number, and we can actually get rid of it because we have 9 times e to the x. We just divide both sides by 9. We're going to get e to the x equals 5/9. Now we can change the log form. It'll be natural log of 5/9 is equal to x. And when you put that in your calculator, you should get negative 0.5878. Alright, and letter J, remember this is base E. So if we change to, now this is actually a logarithmic function, and so we want to change forms here. And we'll talk more about our strategies for logarithmic functions, but we're going to go ahead and switch forms. So it'll be e to the 7th power equals 5x minus 1. And so you can see that I just need to set my exponents equal. So 5x minus 1 equals 7. We're going to get 5x equals 8, which means x is 8/5. Alright, so let's move on to the next problem. And actually, I'm going to go ahead and stop right here. Let's see, which problem? Let me just check one thing here. Whoops. All right.